We're good? Okay. Good morning.
Good morning. Good morning. The program showing Jason Marberry. Yeah. It's Mark Syracuse.
Oh, that's right. Mark Syracuse, because we had printed it. Mark, I'm sorry. Come on up. All right. So, Bob, we did have, yeah.
We did have a replacement. Mark Syracuse is taking Jason's spot. Okay.
Yeah, come on up, sir. Oh, that's right. Okay. All right. Yeah. Mark Syracuse. And John, what's your last name again? Perella. John Perella. They were going to split. So it's Mark Syracuse. Yep. And John Perella. Yes. Yeah. Okay. Thank you, sir. Well, good morning, everybody. I'm going to make the same comments I did in the other hall when I opened up. It's been so long since everybody been to an in-person conference, I forgot how this works. Good morning. There we go. My name is Gene Jones. I'm the executive director for an organization called the Southern Waste Information Exchange. We basically assist industry and municipalities with waste issues. I've been in the industry since 1981, working, it was developed at Florida State University. This particular program actually got started in 1995 when we had a grant, I believe it was Department of Energy, to do a symposium on the redevelopment of manufactured gas plants. And that went back, the first symposium was done in Prague. Since then, it's been done in the UK and a host of facilities here in the United States. If you will allow me, I'm going to make a couple of opening comments real quick. First off, I need to, if I can, ask everybody to silence your cell phones. With regards, as many of you know, we're doing a joint program here. So I've got the Florida Remediation Conference and the MGP Symposium. We are recording all the sessions. So if you have an interest, you can either go back and forth between the sessions. If you catch something that strikes your eye and you want to go listen to, you're welcome to do that. But we are also recording the sessions, and I will send those out to everybody post-event so that you can come back in and look at what you might have missed. All the presentations are being shot to PDF, so I'll send those out to everybody as well. With regard to the receptions and breaks, that will all be in the exhibit hall that will just right down here. We're doing a shared exhibit hall. We have a Top Golf event tonight for those that have signed up for that. That will take place at 7:30 over at Top Golf. Next, if you allow me, I need to thank our sponsors. NREX is our platinum sponsor. Our gold sponsor are IET and Sevenson Environmental. Our silver sponsors are ACT, Aquablock, Airlogics, BSTI, Burns McDonnell, Action Environmental, Cascade, Geosyntec, Halls Environmental, HEPACO, ATES, Terracon, Universal Engineering, Green Rock, US Ecology, and Mechanic, Nuco, and Hearn and Webster. This organization or the conference is being organized by or supported by the Florida Brownfields Association, Environmental University, Southern Waste Exchange, Environmental Industry and Conference Management, the Florida Specifier, and Mothers for Mother Earth. And then conference organizers are ASTM, INSTEP, and Florida State University. Let me also give a little bit of a shout out in terms of marketing for our next Florida Remediation Conference. That'll take place next November 16th and 18th, 2022, back in Orlando, but we'll be over at Champions Gate, which is here in Orlando, just a little bit further down the road. Lastly, as part of the Florida Remediation Conference, the industry gets together and always does a charity event. So this year we're raising money for the Children's Safety Village, which is here in Orlando. It's an organization that provides education to kids. They've educated over 100,000 kids on various activities, from safety in terms of learning how to cross the street, to swimming, to safety belt, car seat belt safety, that sort of thing. So we are actually holding an auction, an online auction, and I encourage you. We've got some great prizes on there, from tickets to the Orlando Magic, to Tampa Bay Buccaneers, to there's a sword fishing trip. There's a whole host of things. So if you have an interest, you may want to pull it up and take a look at that. We've got a sign out by the registration desk that you can pull up and scan and register for that event, or at least look at the items there. I'm going to move forward with the opening session. This session is going to be moderated by Bob Wyatt. Bob is the Director of Legacy of Environmental Programs for NW Natural, and is going to chair the session and take the realms and introduce the speakers and what they're going to be talking about. So with that, Bob, I'm going to turn it right over to you, sir.
Thank you, Gene. And good morning, everybody. The first session is always the best. So we have three great speakers today, and we're going to start with Gary Rose. If you want to see the details of the speakers, you'll have to look at the online and materials information. We're not going to be providing introductions other than the speaker's name, which is Gary Rose. He's with Sevenson Environmental. And today he's going to be talking with you about a former MGP ISS remediation project in New Jersey, which is one of my old home states. So I'm looking forward to this one. Thanks, Gary.
Good morning, everybody. It's nice to kind of be back in the realm of person to person, huh? It's been out for quite a while. Oh, sorry. Any better? Yeah, I said it's nice to be back together again in person. I've got to thank Gene very much for putting this together, and great golf tournament yesterday for a very worthy cause. It was fantastic, fantastic day. So I'm here this morning. We're not going to talk about graphs. We're not going to talk about amoebas. We're going to warm our brains up to start the conference this morning so we can get into more technical stuff later on. So I'm going to present a project that we worked on over the last few years, an ISS remediation project in New Jersey. We got some lessons learned at the back of it, but we're going to give you an overview and the flavor of the projects, and some things that on the engineering side, on the contractor side, on the owner side, that we can discuss a little bit further later on in the program. So I just want to give you just a little flavor of the equipment that we had on site for this particular project. We had a PC 1250, Liebherr 976, very, very large equipment, 21 excavators on this project to maintain some type of production in the field every day to achieve what we did. We got hammers, we had vacuum trucks, 2 Bauer BG45 drill rigs, 3 grout plants, 6 low pro silos, 650-ton storage pigs on the site. The backfill, we had the dozer, we had the roller. And for the odor control, we had, 4 Rushmar Foams machines on this particular project, and 6 SL Super deployment machines for SL Super, Biosolve, something the similar family for odor control. So this is an overall look at the site operations we had within the confines. Again, this is a big site. It's 37 acres, bounded by a very urban area. So if you take a look, we have the BG45 drill rigs, 2 of them on each side of it. We got grout plants. We have 2 grout plants centralized there in the middle. Grout plant third, and the 200-gallon wastewater treatment plant on the outskirts there. We have an oversized debris loadout processing area. We pre-clearing for obstructions. We're doing bucket mixing. We have PC 490s performing ISS via excavators to the back right. And then we are treating some lead contaminated soils to load out of big tight on the bottom. So you can see there's a lot going on this project altogether here in this overview. So this is grout plants 2 and 3. They had all the components from power to storage to producing the grout. On this particular project, we produced 60 million liters of grout for the stabilization, mass stabilization of the site. It's a logistical, I wouldn't say nightmare, but it was definitely a dance out there every day in the field to get the fluidity of everything that needed to happen in that day. There was, roughly 25 reagent trucks, both slags and PCs, coming in every day on this site. All dust controlled, bag houses, perfect setup for what we had to do here and reach we had 750 runs out one way. The next day we'd have to change the grout hoses and move them and transverse to the other way. But overall, worked out very well. We did 155,000 cubic yards with bucket mixing in some, areas of a depth of 25 feet. We've had 2 to 3 to 4 bucket machines going on a daily basis. Some very tough material to get through, but you can see the work and the actual slurry that was being made in this particular photo. On the drill rig side of things, there's a 10-foot diameter drill rig. We did 270,000 cubic yards with a mass depth of 45 foot bags below surface. The drill rigs had a state-of-the-art controlling devices called the B-tronic system from Bauer. It gave us verticality. It gave us crowding force. It gave us blade rotation speeds. It gave us XY axis on all components, amount of grout liters injected, feet per second of injected. And this provided you a great rig report at the end of the day for a QA QC type of report that came out. We could also log into this system remotely. We could watch from the home office exactly what the drill operator was doing, why maybe one drill was lagging behind another. We could log onto the system, find out if he was in harder soils, he hit an obstruction. Think of the data that this provided us was fantastic for QA QC reports. We could download probably about 1,000 columns within the system that we could go find automatically with the GPS, get right over center drill point, and hold verticality down to those depths. So it was a great tool for this project. Oh, I got her back. Sorry about that. So we had some other interesting components to the project. We had on the upper left, we had a new 36-inch gas line and a 16-inch propane line that we had to put in a clean utility corridor. This utility corridor was ISS and solidified first, and then we carved out the ISS monolith and then set the pipe within the monolith. So it was more of a less of a clean corridor. This gas line was very important that we hit the heating window, the distribution of gas in this particular city. It was paramount that it happened, and it was hit within the warm weather months and not in the cooling system. We also had DeWin 1 trench on the site. We did 2,200 lineal feet of cutoff wall on this site, depths up to 100 lineal feet deep. On the bottom left, we had jet grout terminations around this gas line once it was done to make a continuous plug to finish off the 1-pass wall. Depths of the jet grouting were, 80 to 100 feet. A large area on the bottom of the facility. So I wanted to talk about a couple lessons learned here. In the ISS type work in the arena, pre-clearing can't be stressed enough. This particular picture here is probably, we're about 2 months into the project, and the amount of concrete and pier piles that we pulled out of the ground just to enable us to drill were enormous. It was an activity upon itself, besides all the other nuances of the job. I mean, we were pulling out concrete and pipe size of small Volkswagens, processing them, sizing them. So I can't overestimate this, the importance of the pre-clearing here. If they say it's down 7 foot, go 10 foot, because all it does is cause issues later when you're going to get a mix and you have an obstruction, within it. It makes it a little bit easier. Slow the job. You got 60, 70 guys on the job. The ISS drill rig comes to a crawl. You come over, you don't have any advancement on the drill. And then you start getting into conversation with the owner and the engineer about why you can't advance. You didn't pre-clear good enough. You weren't thorough enough with the removal. On this particular one, we put out about 28,000 tons of concrete, and over 50,000 pier piles, wooden pier piles, were removed from the project depth. So the old historical structures on top, everything was supported by wooden pier piles within the hole. So we had a double layer of obstructions to pull out. So we had another issue on the site. This was on a metal mat, which the metal mat is a defining layer between almost water table and the natives or imported soils that are on top. So the platform of this, we were to pre-excavate 7 feet, and metal mat was at -9. So we had a 2-foot buffer between the metal mat and our stabilized platform to be able to work off of. So we found out that we had obstructions, below 25 feet. So what happens? You punctured the metal mat. You puncture the metal mat, you start getting, a tremendous amount of water in your excavation, your platforms, and the stability that you got to put a 500,000-pound rig on start become compromised. So what we had to do is we had to, instead of, you drill and you usually retreat, we had to drill in advance out onto the metal mat. So we pre-cleared areas, of course, and got all the obstructions out of the way. And then we had to work from an edge and work on previously stabilized material in front. And we're working on stabilizing primaries and secondaries in the middle, and then to be stabilized. So what we'd have to do is we had to find long runs where we could run this machine for 200-300 feet of areas that we pre-cleared. And then we'd be able to, take 7-8 days to go down to the end. And then we get all our QC data and everything back from the laboratory, making sure the compressive strength was in order to get the rigs all pre-engineered. We knew the strength that we needed to do. We needed to know the size of the crane mats that we needed to put on it. And then you could reverse and come back, move the crane mats out, traverse on the previous stabilized soil safely, and advance the drilling in a different method, just because of puncturing the metal mat. So good lesson learned on that for us. We also had a very, very urban environment, as you can see here. We had probably within a half mile, we had 25,000 receptors in this area. We had an active path station nearby, had an active facility. The utilities still worked in. As you can see, a little stadium in the backside. So on this particular job, 365,000 gallons of foam for odor control on this. Another 76,000 gallons of Biosolve SL Super on the project, just to control odors on the job. You can imagine a 37-acre site. We had to open up a lot of face. We went through 3 seasons, hot, cold, hot, cold. We all know what happens in the summertime, trying to control this. So I can't emphasize the amount of odor control and concern that we had around the community. We had constant outreach from the owner to the community, and a great group of air monitoring. We'd have odor walks every day, just to try to maintain a sense of troubleshooting the project. But all in all, we did very well. But I can't emphasize enough of odor control. I mean, it's one item that you really don't want to fall short on, especially when you're designing or building. You know, the other issue with this is with all the open face, the stockpiles of material. You know, try to make sure that you have all your disposal options on the table. Make sure you got a recycler. Make sure you can move this material. The longer you have this material sitting around, you know, the more cumbersome, odorsome it becomes. So, you know, you try to move, direct load where you can, stockpile, load out as fast as you can to try to eliminate some of the point sources of odor. And that's all I got this morning, guys. Any questions?
Thank you, Gary. That was great. Our next presentation is by Mark Syracuse, who's with Arcadis, and John Perella with Action Environmental. Got it backwards. I apologize, guys. You can correct me when you get up here. They're going to be talking about remediation site development in North Miami Beach, and really appreciate the energy that you're going to bring to the stage here.
Thank you very much, and thank you for coming out this morning. So today, John and I are going to be talking about a site from Tampa Electric People Gas in North Miami Beach. What we have here, this first slide, is an aerial from 1951. And on the left, you see the storage facilities, the tanks, and the retention ponds. Cutting across the middle of the slide is West Dixie Highway. And to the right of that is they call it the East Parcel. That's the main plant and facility. Then just to the right of the facility is the railroad tracks, and that's Biscayne Boulevard. So today, John and I are presenting, and we're going to talk, as we do most of our speeches and meetings, we like to start with a safety moment. So here on the left, we have old fire main that was on the facility. This fire main served the old plant. And the reason I have it up here, and I'm adding to situational awareness, is as we went out there and started working, we discovered there were a lot of old utilities. And something that was brought to my attention on this job is the lifespan of these utilities. 80 years of sitting out in the ground, that's what's inside the water line. See, it's half full. This water or fire main really had no more use at the site. And as we went out there, we discovered that we were able to take care of probably a future problem for them. Having this out there, the valves weren't working, starting to leak. So we were able to roll this into our project while we're working out there and take care of an issue that probably would have come up sometime in the future. And then this other slide, if you see just to the right of that white building, you see the water spout, the tornadic activity. One of the things that we've done at Action to help increase our situational awareness is we've included apps, weather apps on our phones. We've gone to the safety department and evaluated some that are we've choose to use company-wide to help us identify dangerous weather situations. As you see here, we were working along, putting down asphalt, remediating. We had no idea of the tornadic activity. It's a beautiful day at our site. No real indication. Without that warning from the weather app, we wouldn't have known this. The Arcadis oversight had got the warning, went out, looked around, found it, took a picture of it. So it's not every day you get to have a picture of a tornado in the background of your site. So with that, I'm going to turn this over to John and he talk a little bit about the history and remediation.
You guys hear me? Okay, so as Mark alluded, the site is split into 3 sites. You can see on the map here, we've got west parcel, east parcel in the center, and what we call former melting pot off to the east. These are all brownfield sites, between west parcel and east parcel is West Dixie Highway, as previously mentioned. Here's a little bit of the history you guys can read. Operations for about 30 years. It's converted to natural gas distribution, which it still does today. The pilot test that mattered, or that we're currently following right now, is the biosparge pilot test, which started in 2010. And you can see the about every 2 years we did construction on this. Is this? There we go. Okay, so I'm going to go through remediation quickly. We're doing biosparge and SV at this site currently, but initially we did some soil excavation. So the west parcel is where we started, excavated, and then just more recently we did the east parcel. Typical stuff here: excavation top 2 feet, stained soils. We followed them down to the water table approximately and removed old structures. The picture there at the top left is the delineator fabric that we have on the east parcel. It's obviously orange. That separates the excavation from the non-excavation. You can see there below, we're pulling out a foundation for a tank as well. On this particular site, the excavation really covered almost the entire parcels. On the east parcel, for instance, the only things that were not excavated were the buildings. Everything else was pulled out. And then also, excuse me, the regulator station, which you guys may see next to the building there. Okay, so some interesting things about the remediation were the challenges we had with the installation. This is the west parcel. This is where we started first. Biosparge system, like I mentioned. The challenge we had here was West Dixie Highway was recently paved and the city would not allow us to touch their asphalt. So we had to bore under the road. And with the amount of utilities out there, it was really, if we could look to find a way to not do a jack and bore under this very busy road, we were looking to do it. So to our benefit, there were 2 36-inch cast iron pipes that traversed the road between west parcel and east parcel. So we're able to utilize these pipes for our infrastructure. So saved us a potential utility strike. One challenge, I guess we would say we had is this put our SVE lines a lot deeper than we wanted. They're about 8 feet deep where we might want them typically around 2 or 3. So we had to install a sump on the east parcel side of the property because of that. Just moving on, I'm going to go through all of the different parcels. This is the former melting pot, much smaller transect of biosparge wells. This is a kind of a typical, almost like a gas station type air sparge system that you might have at some of your sites. The interesting thing here is we recently were able to get approval from the regulator to turn off the SVE system entirely. So we're just operating with the biosparge. The SVE, just so you guys are aware, was really put out there for methane control, which was a big concern for the regulator down here. This is Durham that runs this one. Moving on to the east parcel, this is our one of our larger transects. 63 biosparge wells operating in 8 zones. Here, the interesting thing we did here is that this is a picture of the inside of the historic compressor building at the property. This is a building that was built in about 1920, and as you can imagine, this being in North Miami Beach, Miami area, property is very valuable. So we were trying to minimize our impacts or how much property we used up with our equipment. So this was a historic building. It had to stay in place. So we utilized it as to store our equipment in it. So we moved some of it was previously used just for equipment storage. We moved some of that stuff out of there and put our equipment in there. You're looking at the blowers for the SVE system are there in the front, and the air compressors are in the back there. So this is both the east and west parcels are situated in this building. And then just closing up before Mark gets to talking about redevelopment. Another thing, as we touched the asphalt on the east parcel, stormwater came into play, and we had to do some improvements to what was there. Like I mentioned before, we had to maximize the usable property, but also considering the nature of the site, infiltration was really off the board. So detention had to be contained. So what you're looking at here, and Mark's going to talk about it for a little bit as well. This is a product called Storm Trap, and it's a concrete structure used for detention of stormwater. This particular system, you can build it without a concrete floor or with a concrete floor. We built this one with a concrete floor, so everything is contained within those structures. There's two of those. One is on the north end, one's on the south. The south is a little larger, as you can see. These structures discharge into injection wells, and that's the picture at the bottom left there. That's one of the injection wells. That's the vault being installed there. And these injection wells are designed to, they're cased to approximately 80 feet, and they discharge below any groundwater impacts. So this was a way we were, again, able to maximize the owner's property usage and also avoid impacting our groundwater plume. So I'm going to pass it on to Mark. He'll finish up.
Thank you, John. So in moving to the installation and remediation of the site, when we showed up, most of the site, as you can see in the pictures here, was gravel and grass, dirt. There was a small area in the south that was actually paved and used next to their facility. The rest of the area was the lay down and storage. So when we first got there, we had to do an unusual clearing and grubbing. We were able to get there and help TECO. You see here on the left, the side of where the SVE wells are, we had to go and help them. They had a lot of old stuff. They'd been there since 1900s. So with most people who were around long, you start collecting and having things. So we were able to help them. This picture on the right's a piece of equipment that wasn't working. You see, we had a tree growing through the engine. We came there with the big equipment, and we were able to pick up and move and help them load this. Things that they weren't able to do themselves. We were able to get there and start. And when we started the remediation, we also came in and helped clear their site and make it available. One of the things that is unusual about this site is that it had to remain active. This facility services the whole Southeast Florida, and all of the emergency response, all of the utility strikes, breaks, repairs, leaks are run out of this facility. This facility had to maintain operation 24/7, 365. We could not shut the site down. We could not impede their work at all. Made it very challenging. And what I'm going to talk about here with the way we did the work and how we did the work makes this a little special. We had to segment the work and jump around in order to allow for them to continue full operation. So one of the things we did, here's a typical contamination you might see at MGP sites: the tar, the goo. The middle and right picture are the tar pit by the old historic building. So a big concern there, because this is an active site and TECO has people showing up every day to work, we had to make sure that when we did these activities, we weren't exposing the workers. This was a concern of TECO, the regulatory agencies, Arcadis, and ourselves. We wanted to make sure that everyone who worked there was safe and not exposed. So this took some special steps. We had to put physical barriers, temporary fencing, at a safe distance to keep the people from coming up or going in our work zones. and also to keep them from being exposed we had constant air monitoring. This pit, when we were digging it, we had to go to level C because of benzene. There was another area on the site where the same thing happened. And it was a great concern that people just coming to work every day aren't exposed to this. So what we did is sequenced this whole site. We divvied it up, and in order to take land from them that they were using, we had to provide some place on site for them to use. So we went and started with the north end and cleaned and prepared the north side of the site, brought it up to asphalt, and then cleared the western section to give them a clear corridor to the building. So as people came to work every day, they could park and then go, because currently they park down south. And as you'll see in some slides later, we completely took their parking to finish this project. We worked from one fence line to the other. This entire property had to be remediated, and the trick was keeping them operational the whole time. So here we are on the west side, clearing the west side down to the building. And here's one of the regulator stations. You can see from the pin flags on the left, we have a lot of gas lines coming and going there. So that's all handwork. We had to get out there, excavate by hand. And in the middle picture, you see we have some MGP lines on top of the active gas mains. Those all had to be removed. They had to be cut out and removed very carefully. With that facility right there supplies all North Miami Beach and Miami Beach with gas. And of course, being a 100-year-old facility, there's all kinds of utilities out there. We took a lot of effort, did some geophysical investigation, identified tons of anomalies, and had to go out and do some soft digging. That picture on the right is us going out doing soft digging, trying to identify the anomalies and figure out what utilities were live and the myriad of utilities that were no longer active out there. So once we'd completed the north side, we had a west side corridor for the employees to park their vehicles and then walk down to their facility. That facility is a call center. It takes the 800 numbers for emergency breaks, hits, and responses. That facility had to remain open. People had to come to work every day. So we had to make sure that they had a nice, safe pathway. We looked at many options, spent a lot of time trying to figure out how to get them from the north side or from somewhere else. We thought about parking them off site, busing them in, having them park across the street and crossing West Dixie. None of those options were really viable. We came up with this corridor, and my operations manager, Josh, had found this product. This blue runner is designed for people with disabilities to gain access to beaches. It's designed to be laid out across the sand to give them access to the ocean and beach. We took this product, utilized it here, and it worked beautifully. Instead of having to build a sidewalk or put down temporary asphalt, all costly and wasteful, we were able to use this product, and it was recycled after this project. It was given back to TECO, and they used it at another facility. A really great solution. So here we are with the drainage wells. On the left, that is the drainage well in the front. Now, these drainage wells were put towards the edge of the property. We had to go down 20 feet. There was no way to safely do that between the building and the sidewalk. So we had to install sheet piles and build a cofferdam around both of these wells. The one in the north was also up against the property line. So we went in, and you see here on the left, we're installing sheets, building cofferdams. And in the middle picture here is the bottom half of the control structures to go over that well. These were enormous structures. They came in two pieces, two different trucks. We had to set them. And then in the far right one is the top half of the drainage structure. So here we have on the left, the bottom piece already installed in the cofferdam in the front of the property. So in planning this out and thinking about it ahead of time, we're like, well, once we get in there, what do we do? Because it's confined space entry. It's not easy to get to. So how are we going to disconnect the crane? You can't have it sit there for a day. So again, Josh had come up, he saw this gangplank. They go get a portable one, and we utilized that. On the right, you see that's the northern well. We put it across there, and we're able to go check the elevation and placement of the bottom structure, and then go ahead and disconnect it safely without having to get into the structure itself. So here we go. This is the real estate part, right? We took up everything. This was John was talking about. You can see from the picture on the left that drainage structure takes up a tremendous piece of the property. The whole southern parking lot was basically taken. So before we could do this, we had to displace TECO, which we put them to the north of the old building. And we even rented a property across the street as a laydown area for their piping. Because as well as repairing utilities out of this yard, they also support all the construction in South Florida of the new lines and upgrading of lines. So every morning, 20 or 30 contractor trucks roll in to get loaded with these pipes and features from the warehouse. All of that activity had to go on every day. We couldn't shut them down. So we had to figure out ways to get them in there. In the middle photograph, you'll see we have their pipe and some of their emergency response vehicles nestled in with us there in the middle of the property. Again, through coordination, maintenance of traffic, signage, spotters, we were able to make all this work. And there on the right is the foundation for the storm trap. It's formed out, rebars in there, 1 foot on center, getting ready for the pour. So here we have starting the pour. On the left-hand side, we have the enormous pump truck. That's about 2 in the morning. We started this pour. And the one in the middle is that's about 7, 8 o'clock in the morning. We're down to the last 3 or 4 truckloads, getting it in place. And then the photograph on the right there is about noon, 1 o'clock. We're out there finishing it and leveling it. This slab had to be perfectly on grade and smooth in order to place the pieces of that storm trap. The tolerance between these pieces when they're set together is very small. They have to fit together perfectly like a big jigsaw puzzle. So it was very important we had this finished properly. About 5 or 6 that evening, we were doing the relief cuts on the slab, and then it was covered and tarped for curing. So here we have the installation of that storm trap. This was a pretty big undertaking at this project. One, because these structures were somewhere in Central Florida stored and set aside for us, and they had to be trucked in. And again, every single piece had a specific location on that slab. If you can see on these structures in the first picture, there's number 2 and 3. They were numbered. Everything was put together. We had a map as we had a guy on the slab as the crane was bringing them down, placing each structure where it had to go. This took tremendous coordination. We're loading these trucks the day before in Central Florida. They're coming down. They have to arrive in order. They have to arrive in a time sequence so we could place them and get them off. And the whole time we're bringing 20 semi trucks through TECO's property, we have to keep them operational. So we spent a lot of time talking and planning with the local people, keeping them operational. You know, and like anyone who's had renovation in their house, it's annoying and it's frustrating to have someone come in and disturb your house. And we were there for 2 years. So they had tremendous patience and they were tremendously helpful to get this done. And this took a big team effort. Here on the left, we had a 250-ton crane setting these. We could only reach halfway across the pad. So we had to set up north and south. So here on the left, we have the south setup. We're finishing out, placing the pieces. In the middle, we have the structures all in place and we taped all the joints. All the joints were sealed with a mastic type tape and the bottom as well. As John said, this was not an exfiltration. It had to hold the water and then it would gravity flow into the well. The flow line is flat out of the structure. It's an elevation 4 all the way to the well. So the water just finds its way, and during rain events, it builds up here and then runs to the wells over gravity. And in the right here, we have the structure covered with fabric and ready for backfill. We backfill with clean wash sand. And one of the unusual things, and one of the things that I think was very beneficial for this project was having one contractor not only do the remediation, but also do the restoration, because we were able to plan. All this hopping, skipping around over 2 years would have been an absolute nightmare if we had a secondary company out there doing the restoration, because they would have to come and stop, come back a year later and finish. Under one roof, under one control, we're able to plan ahead. And this picture is an instance of that. We had the surveyors come out and we had them plowed out the parking islands, because under asphalt, Dade County, you have to have chases, 4-inch chases for all the irrigation pipe at 36 inches in depth, which puts it right on top of the structure. So 4 or 5 months later, irrigation's coming out, but we had to have this planned out. We had to have it installed. And the same thing with electrical conduits and everything else. As we went along, we built everything as we went in pieces and tied it all together. So in the end, it was seamless and much more efficient. So here's the final product. We have on the left here, you see the historical building in the middle. In front of that, where all those white vehicles are parked, that was where the backhoe was with the tree in it in the MGP station. That is now long vehicle parking. So the trucks can go and they can stay attached to their trailers and be ready to go at any time before they have to park them and park someplace else and go hook up to them and go. So they can pull in and pull out, no backing, which is a safer way, which is the way TICA prefers it. On the left-hand side there, you see a metal structure. That's a new metal structure we constructed for a CNG station. They have a compressed natural gas station, which they use to fuel their vehicles, or some vehicles of theirs. That's going to be reconstructed and back in action here in a few months. The center photograph, it shows their new parking area. 98 parking spaces with medians. The trees, there was over 5,000 plants and shrubs planted on this facility when we did restoration. All new grass, all new irrigation, new curbing, enough parking for all their vehicles. In the middle slide in the top, we built a new storage shed for them. So they have new covered storage, built a new forklift ramp, getting it up to code. And in the far right picture there, we have a shot of the landscaping, the palm trees, and the beautification of the site, as well as 2 new gates. We put in 2 new electric gates for them to make access and entry more efficient. And with that, I'd like to thank you for coming out today. And it was a pleasure sharing this with you. And I hope you can enjoy the fact that we have a beautiful new modern looking facility for TICO. Thank you. Any questions? Yes.
It was pretty rapid. I'd say the methane issue was transitory, for sure. I'd say within 6 months, methane concentrations were not really an issue coming in. The question was, were we developing anything else that was of any significance? And so that the study that we did was looking at other utilities that were nearby operating just the biosparge system. What effect did we have on those utilities? And what we found in the study was not much. So we were able to shut it off. Yeah.
Okay. Thank you.
Thanks, John and Mark. One of the things that I wanted to mention to folks, the agenda was printed and there was a speaker change. So if you want to see the profiles for the speakers that you just saw, they're on the online access page, but what's in your printed materials is incorrect. Our third and final speaker for the morning is from Geosyntec, Jim Langenbach. He's the Senior Principal Environmental Engineer, and he's going to talk about remedial design, remedial action, implementation results, and lessons learned at an Orlando former gasification plant site, Operable Unit 1.
Thank you, and good morning, everybody. Forward to talking to everybody this morning about a project that's consumed essentially the last 7 years of my life. So boiling 7 years down into about 17 slides. So I'm going to run through a little bit of site history. This is a super fun site. So we went through, there was a ROD associated with it that selected the remedy. Remedial design, the RD, or summary of the RD, as well as the remedial action RA. And then kind of get into some of the results. We've been implementing the active part of the remediation system out there for just over a year now. So we have 1 year of sort of post data collection that I can share. And just like any MGP presentation, it wouldn't be an MGP presentation without a classic old image of what it looked like back in the day. So there's your, early 1900s shot. Basically I've kind of identified the vantage point of where that photo was taken here, and the site's actually in downtown Orlando. And it covers a number of different parcels in this downtown area, which I'll be discussing. So as I mentioned, it is located right here in Orlando, downtown area, right in the heart of downtown. It's adjacent to the UCF downtown campus. It's bounded on its north side by CSX rail lines, surrounded by commercial buildings. And then you have a natural gas distribution hub located in the southern parcel of the site. And then of course you've got a network of city streets and right-of-way areas that are also part of the project area. Sort of just zooming in on that, you'll hear me refer during this talk to different parcels, and this just kind of highlights some of those. Just on the north side there, starting on the west, basically parcel 1, 2, 3, 4, 5, running west to east, and then the larger parcel on the bottom is parcel 6, and then we kind of call it the streets and right-of-ways. We kind of just coined the term parcel 7 for that. You can see the CSX right-of-way running along the top of parcel 1 through 5, and then just beyond that is UCF related building infrastructure. So a little bit of the history. This was a former MGP operator from 1887 to 1959. Those operations introduced MGP residuals into the environment. There was a multi-party PRP group established in 2002. So there is several entities that are contributing to the cleanup of this operable unit. Remedial investigations were conducted in the early 2000s to about 2012. At that time, the RIFS was prepared, authored in 2013, and then essentially the record of decision 2013 was selected for OU1. OU1 at this site is essentially the surficial aquifer, so 0 to 60 feet. Out here at about 55 to 60, it varies, but you hit the Hawthorne clay. So everything Hawthorne clay up is OU1. And then essentially, I'm not going to be talking about it, but OU2 is another whole big issue, but OU2 is groundwater associated with the Floridan aquifer, so down a couple hundred feet. You could generally see in the old sort of historical aerial image, you had a lot of operations on the north side of West Robinson Street, but then you also did have, big gas holders and such on the south side where parcel 6 is, and those were basically used for sort of the distribution network. So as you can imagine, a number of pipes crossing West Robinson Street back and forth as this facility was constructed, and then over time, modified and built and added to. So before I really get into the remedial action, remedial implementation, I wanted to go a little bit through some of the general elements of this site and the ROD, basically what we're having to comply with as we do implementation and design work. So it covered excavation, disposal of surface soil. So that's 0 to 2 feet, basically on all these parcels 1 through 6 in the right-of-way areas. ISS of mobile NAPL, removal and disposal of former MGP structures. And I'll go back when I say mobile NAPL, that was basically, we ended up developing a definition for mobility to define what mobile NAPL actually was, and obtain EPA and DEP approval on that so we can go out and characterize actually what is mobile NAPL. D&D of buildings out there, parcel 2 and 3 had some different structures that were going to be coming down. An engineered capping system around the footprint of essentially the source area, which is area that was defined with elevated groundwater concentrations and MGP residuals. Installation of an ISS barrier wall around the perimeter of the source area. Hydraulic control within that barrier wall, or some mechanism to keep the head down inside the wall. Implementation of short and long-term groundwater monitoring program. And then following that short-term groundwater monitoring program, implementation of M&A or biosparging, depending on what the results of the short-term monitoring look like. And then, of course, identifying, implementing institutional controls associated with the project. So Geosyntec basically got involved in this project right after the ROD was executed. So one of the first things we were involved with was the pre-design investigation, all the work plans leading up to that, and then implementing these pre-design investigations. One of the things that we did find early on as part of the pre-design investigation was that the dissolved groundwater plume north of the railroad lines has much higher concentrations than were shown in the RI. So based upon that, it was pretty obvious that short-term M&A wasn't going to be an effective solution for groundwater, and you'd ultimately would have to be doing something down the road from an active perspective. So we actually used that as part of our discussions with the agencies to come up with some other modifications that facilitated constructability of ultimately the barrier wall remedy, which I'll discuss. When we did the pre-design investigation, we didn't find any mobile DNAPL, but we did find 2 areas of mobile LNAPL. You can basically see on the bottom here, they're kind of in the area of parcel 2 and 3 on the north side of West Robinson Street, a couple pockets of what was identified as mobile LNAPL. We did ISS treatability studies, and then also refined the barrier wall footprint. So the original wall configuration was the blue line. That represented obviously some pretty significant challenges because you'd be crossing a major street, a roadway. There's an 8-foot diameter storm sewer pipe that would run right through the property. You've got a whole host of utilities, gas lines, overhead power lines, and other issues associated with putting that barrier wall in that blue configuration. What we were able to negotiate with the agencies was a final barrier wall configuration. And this, of course, considered our results of our design findings. Our pre-design investigation really was able to hone down on the area where the source area was located, so we could reduce the size of that barrier wall. And as part of that reduction in the barrier wall and the negotiations, we're going to, instead of holding off on doing active remediation and going through a period of M&A, which we knew wasn't going to work anyway, given the fact that the concentrations were as high as they were in the dissolved portion of the plume, we were going to go directly into active remediation, which made sense too, because when we constructed the barrier wall and did all the surface soil removals, we could put in the infrastructure for the active groundwater remediation system outside the barrier wall. So that's kind of how we worked that out. At this site, the preliminary design investigation work facilitated the preparation of a 60% design. So once we got to the 60% design, we got that approved by the EPA and DEP, and then went with that document out to bid and contractor selection, and also used that to do community interaction and community presentations. So I'm gonna get into the remedial action, the construction work. Basically, I break it into 3 different phases. Phase 1 is surface soil removal work related to parcels 4, 5, and 6 and adjoining right-of-ways. Phase 2 is sort of all the heavy hitting barrier wall, soil surface caps, MGP piping removal, separator basin, all that type of stuff. And then phase 3 is the groundwater remediation related elements. They all had some overlap. Phase 1 was a surface soil. We basically prepared a surface soil removal work plan for parcel 4, 5, and 6. This was actually performed in advance of the RDRA work. It was a way to demonstrate progress. The agencies really wanted to see some progress. The city wanted to see some progress out there. The community wanted to see some progress. So we advanced part of the project outside the scope of the main remedial design. And handling these surface soils that way was something that was easy to do in terms of being able to advance the project along. That work was implemented by Action Environmental from May 2018 to October 2018. Involved, like I said, the removal of the 2 foot of soil. You can see in the yellow area, the areas we're talking about, basically the large parcel 6 area and then parcels 4 and 5. We're basically replacing those concrete parking areas, sidewalks, 2 foot of clean backfill in the pervious areas. Parcel 6 was, a lot more complicated than just going out there and ripping up 2 foot of surface soil. It was an operating facility. It needed to stay operational. That facility was divided into quadrants with the removal of 2 foot of soils and then the surrounding streets, and just done in staged elements as it was taken care of, as well as removal of these large former gas holder concrete pads, and then replacing everything and doing restoration work. So that phase 1 basically involved removal and disposal of a little over 5,000 tons of soil, almost 2,000 tons of C&D debris. Some lessons learned associated with doing all this work on these smaller piece parts. Utilities, locate them. And beyond just getting your 811 locates and having private utility locates, really consider the institutional knowledge of actual facility personnel, because they know a lot. That even these sites, as you all are mostly aware, they're a hodgepodge of layer caked utilities and pipes and everything else. And while a private utility locator may figure out most of what's going on, he may miss something. And in a few instances early on, we had that happen where gas line was only 6 inches down and nobody knew that it teed off and had a little branch. But then when we talked to facility people, oh yeah, back in 1982 we did, so once we kind of figured that out, it was like once we'd go to dig an area, we'd get all the utilities marked and then bring out all the people with institutional knowledge and walk it and say, okay, what else do you know that the magic marks on the pavement aren't showing us? So that was very helpful. These holder pad slabs are a lot thicker than the GPR led us to believe. They were 2 foot thick, rebar reinforced. They actually were more like 5 foot thick, rebar reinforced. So something to keep in mind. Anticipate increased duration due to logistics. If you're doing a project and you're doing it in all these little quadrants and having to move around, just expect it to take longer to do it right, because there's a lot of logistics involved with implementing things in phases like that. What we did learn doing this work of this first phase, it gave us a lot of good information, and we learned a lot for then implementing phases 2 and 3 successfully. Phase 2, the contractor Forgen was selected at that 60% design phase in March 2018. And with Forgen on board, we then worked to finalize the final design, get that submitted and approved by DEP and EPA as of September 2018. And then after finalizing that design was a whole flurry of work plans associated with implementation and permitting and such, so we can actually get out in the field and begin working. We also established and implemented a third-party multi-station perimeter air monitoring program. That perimeter air monitoring program, using four or five different stations around the periphery of the site area, was initiated a month before construction began. Phase 2 construction was initiated in April of 2019, involved some initial demolition of buildings. DPT coring, one of the things we did around the entire periphery of the barrier wall was every 20 feet to satisfy the agency's needs, did coring to visually confirm the actual contact depth with the Hawthorne formation. So we can then basically confirm the exact key in depth for the barrier wall panels as we continued around on the project. Clearing of obstructions. I know the first talked a lot about clearing of obstructions. Again, that's a big deal at this site. Lots of historic, I call it industrial archaeology. You just see the layer cake of, back in the day, the way to redevelop or add on to an MGP site was just push the old stuff down, bury it in a layer of concrete and build the next layer on top of it. And you literally would see the layer cake of construction over the decades. Clearing of those obstructions, pads, debris. We found a rebar reinforced vault that was unknown. That was basically a 23-foot deep rebar reinforced vault, basically full of coal tar, of course, right against the CSX right-of-way rail line. So some interesting challenges with that. So a little bit about the barrier wall design itself and the ISS. is designed with an average this is based upon the results of the treatability testing and modeling. Average hydraulic connectivity of less than 10 to the -7 with no sample greater than 10 to the -6. Minimum barrier wall thickness of 2 feet, minimum key into the Hawthorne group sediments of 2 feet, UCS unconfined pressure strength of 24 PSI or greater, total barrier wall length of 1,002 feet. It started out, when I showed you the original, it was a little over 1,400 feet, final total length of 1,000. And it was ultimately constructed using a panel construction method, Bauer CSM rig with overlapping and staggered panel construction. So basically the sequence on top will show you, you're doing a panel, you're moving over several feet, doing the next panel, and then basically coming back within the next day or two and cutting with an overlap between those panels and just working your way around. And then the 2 NAPL ISS areas were had to meet those same hydraulic conductivity and strength criteria, and those were bucket mixed to a depth of 16 to 18 feet or so in those areas. The barrier wall construction occurred from May 13th through July 2019. It was a double wheel cutter soil mixer, 25-inch width. The cement plant was located on parcel 1. Parcel 1 is just west of or outside the barrier wall. So that was where the cement plant was located. Total of 148 panels, an average depth of 57 feet. CQA samples were collected throughout. The results of those CQA samples revealed a 28-day unconfined compressive strength, that was greater than 24 PSI, substantially greater, an average hydraulic conductivity of in the 10 to the -9th, 10 to the -9ths, and a maximum value of 6.5 times 10 to the -8. So we greatly exceeded the design requirements for the barrier wall. Just a couple shots of the cement plant. The rotary cutter head on the Bauer rig, and actually, sort of panel construction. I got a little video clip showing some of the construction along Robinson Street. You can see the handy dandy, the rig with the giant tarp over it. That was basically like a mud splash. So as mud would splash, it wouldn't hit go out into the street and get cars or anything. So that actually was kind of, worked real well. And the cutter was able to, using the CSM rig, they were able to run along where the utilities were without having to take them out of service. They were just able to shield the utility lines. Some lessons learned: that the DPT coring really provided a useful mechanism for making final adjustments to the barrier wall depth. I mean, the elevation out there is flat, but the depth to that clay does undulate a little bit. So we were able to, it was about a 4 to 5 foot variation in total panel depth throughout the project area over that 1,000-foot run, this 1,000-foot area encircled. Even with pre-clearing of the wall, we still had buried debris issues. I think that was, first talk discussed the buried wall debris issues. That was a problem. I'd say, something that you're doing design work on these sites, plan for those type of things. You're gonna come across it, even if you pre-excavate your whole length of your barrier wall, which was what we did here, down to 10 or 12 feet. We still ended up hitting stuff. And again, don't trust your underground utility markings and surveys. We found City of Orlando water lines that they didn't know they had water lines, or they said they were not our lines. We're like, well, we got potable water, coming out of the ground. It was underneath some of these old MGP pipes, so just keep that in mind. Additional, items done during that phase 2, the ISS of the mobile NAPL area is the excavation of a tar separator basin, large tar separator basin located on the site. That was done on basically all that was removed within a couple days, which was good, because that was the one portion of the project that really had some odor related issues. Then basically, after doing this, going ahead and removing the surface soils associated with parcel 1 through 3. And as they started doing this, they started transitioning into phase 3, basically installing the remedial system piping and stuff. Lessons learned: that tar separator removal portion generated the most odors, and odor control foam really worked well for abating them. And, really, they minimize that handling and maximize that rate of removal to minimize those odor-related issues. West Robinson Street was a big deal. There was the design identified 9 pipes and 6 crossings. We were looking at removing about 2,000 square foot of road. And the road is underlain by historic bricks. That became a big issue, dealing with the historic bricks. We implemented that December 2019 through January. Ultimately found 23 MGP related pipes crossing the road, and ended up requiring the removal of a 450-foot section of roadway. 14 of those pipes we removed. 9 of the pipes we basically got EPA or DEP on site. We opened them. There was no MGP residuals in them. They approved that they could basically remain in place. So there was some pipes that were left in place. We ended up having to remove over 12,000 historic bricks, count every single one, because we had to replace them all. And then 20,000 square foot of street needed to be resurfaced when we were done. Lessons learned here, count on the smallest item to be the biggest headache. Those historic bricks probably, had multiple conference calls with 5 to 10 attorneys on them, haggling and debating on how to handle a historic brick issue. Never would have imagined that you can spend so much time and effort dealing with some silly bricks, but here we did. Expect some significant uncertainty with regarding the routing of these pipes at these sites, and the fact that a lot of times they're on top of each other. Just because your utilities and your maps and everything you look, your records show that there's one pipe, doesn't mean that there's 4 different pipes as they rebuilt things on top of each other. A lot of times they just use the same routing, so you see sort of layers of 3 and 4 different pipes on top of one each other. We worked out real well with working with the agencies to sort of help us with some real-time decision-making out in the field and plan ahead. So once we had the road open, we knew we were putting in a remediation system. We put in a whole bunch of extra conduit and pipe chases so we can run remediation system piping through it for phase 3, as well as plan for potential what could happen at OU2. Phase 3 involves the air sparge SVE system. Trenching, there's over 2,000 foot of trenching. We installed 5.6 miles of installed piping in the ground associated with this. Did a jack and bore beneath the CSX railway as a carrier for piping runs for the sparge and SVE systems. Directional drilling, put in an infiltration gallery outside the barrier wall. And on the east side where there's not groundwater impacts. We actually then also, as part of the remediation system infrastructure, put in these manifold box systems. You can see one set up in the upper right-hand corner that basically lets you have zoned operation where you're blowing air or pulling water. It goes to these manifolds, and you can do your O&M. You just open these cabinets and making adjustments right in them. And it was the installation of a turnkey remediation system in a shipping container provided by PRM. The bottom right photo. Just a crazy picture showing all the sort of the layout of infrastructure. You've got really the center of the project is parcel 2 and 3. You see the black line, data dash line, that's where the barrier wall is. And essentially surrounding that, you've got a network of air sparge wells, which are the orange. Soil vapor extraction wells, there's only 15 soil vapor extraction wells. They were basically located running along where you have building structures. So along the building to the north, a building on the west, and the building on the south side is where the SVE lines were run. And then a system of extraction and re-injection wells that were put out there. And you can see the area of mobile NAPL. And the blue lines are all the sort of the pipe trench runs with multiple pipes running in them. So the air sparge systems, 51 sparge wells. A lot of these wells are actually angle drilled. So we could actually, you start at a location like right next to the wall, or actually even in some cases inside the actual footprint of the wall. So we can keep it on the PRP's maintained property. And then the sparge wells are angle drilled and getting out up underneath the right of way to the target depths. As 51 sparge wells, 25 horsepower compressor, and it's got multi-zone operations cycled with lots of flexibility in terms of the operation of that system. Manifold systems out in the field for then adjusting individual flow rates and pressures. SVE system is just intended to mitigate potential vapor accumulation underneath buildings. We've got 15 SVE wells, you've got vacuum monitoring points, and a manifold system for recording that data. And it's actually a dual blower system. There's a 20 horsepower and a 10 horsepower system. They run it, they're basically in parallel. Once we've started up operations, we're able to pretty quickly transition. We only run the one system at this point in time. Groundwater research system. So what we wanted to do is when we did the modeling at this site, when you put a wall in, you get this big stagnation zone on the down gradient side of the wall. We wanted to do everything we could to influence groundwater movement, create a dynamic environment in the subsurface outside the barrier wall. So the groundwater, while the primary remedy outside the wall is sparging, the groundwater research system was installed to just enhance movement, contact, and distribution of aerated groundwater, clean groundwater, and movement in the subsurface. So it involves 7 extraction wells, 8 injection wells, a pneumatic pumping system. And the way it was designed, the 7 extraction wells and 8 injection wells can be flip-flops. So we can basically, it's all set up so we could replumb and turn an extraction well into an injection well and an injection well into an extraction well. And then you have 3 effluent disposal options for flexibility there as well. We can go to the infiltration gallery. We have the injection well network, as well as discharge to sanitary sewer. And typically at any given time, we're putting a small portion of the flow, 20% or so, to the gallery, and then the remaining portion goes to the injection wells. We've rarely used the city sanitary sewer, but it's there in the event that we do need to use it. The system was started in July 2019, routine O&M, during startup, system sampling initially monthly, and then kind of now getting transitioned more into a quarterly program, semi-annual sampling reporting to the agencies. Some lessons learned associated with sort of these operations. Having multiple discharge options and operational flexibility has been in key. It lets us optimize and really make changes to the system to benefit its operations without having to jump through a whole lot of hoops or doing design addendums and things like that. For these more complex systems, include a lot of start activities that involve debugging. You're not just going to go out there and turn the switch and everything runs perfectly. There's a lot of debugging in terms of optimizing your operations. The pumping system out here, since we were using air sparge, we figured we might as well use pneumatic systems for pulling water, since we already have air running out to these different manifolds. But for these pneumatic pumping systems for water, includes some enhanced well development. We did find that we had some issues early on during the first 6 months. We were pulling quite a bit of fines and stuff into the wells. We probably did, and if I was to do that again, I would actually do a lot more robust of a well development on those when we're using pneumatic systems. And then the other thing I would note is to provide extreme clarity regarding responsibilities associated with internal system connections. So we had it pretty clear. Remedial, equipment vendor delivers system to the site, and it's a plug and play turnkey system. Remedial contractor offloads, connects his piping to the front end and the effluent to the back end. The question becomes, make it extremely clear who's responsible for connecting all the little pieces internal to that. We made it clear to the equipment vendor that it was their responsibility. They had some disagreements on that. Ultimately, they did do all that internal connecting, and it was pretty clear. But I would just say, when I do this again, I will make it crystal clear who's responsible for those internal connections related to these system components. Some results. This is basically their first year of operation. Treated over 3 million gallons of water. This is the groundwater outside the barrier wall. The footprint of the plume has been reduced by 41%. We've got a potentiometric surface that minimizes stagnation. We see strong concentration reductions of our primary COCs, benzene and naphthalene. On the right is benzene. That's a log scale. If I didn't do a log, it would look fantastic, but on log scale, you see it's a little better distinction. The SVE system is providing the sort of desired vacuum influence under the buildings, even though we really don't see anything. It's sort of just the PRP group wants it because it represents a safety element. The barrier wall has effectively isolated that source area. We basically pulled the water table down inside the barrier wall, and we have pneumatic pumps hanging at that depth that basically like doesn't pump anything anymore. So it's really showing we've isolated and isolated that system. This project involved about 70,000 hours of work during the remedial action implementation with 0 OSHA recordables. So we're proud of the safety record of Geosyntec and all the subcontractors and contractors. They did a great job safely implementing the work out there. The benzene, again, you can see some good reductions in our benzene concentrations over time. We're not trying to get this site down to essentially 0, that's for sure. The goal is to reduce the concentrations down to at or near Florida's natural attenuation default concentrations, or a point where we reach asymptotic stability that we can then petition basically that we've got a stable dissolved plume area. Optimization's been key. We increase and or decrease air sparge rates where needed, and we've turned off sparge wells in areas where the groundwater is cleaned up. We don't need to be running them in there, putting more air where we do need it. Changing the cycle frequency of our zone operations, how we cycle and pulse our operations of our sparge system. Based on what we're seeing, we can respond to that, increase frequencies, duration, contact time, that sort of thing actively as we're doing our O&Ms. Same thing with the groundwater extraction rates, injection rates, how much we're extracting, where we're extracting from, and where we're injecting it to. We keep changing and moving around. So we're kind of continuously creating that dynamic environment in the subsurface and continue that optimization process. Just a closing shot, just showing you a quick, at this site, you basically used to have a groundwater potentiometric surface that was just straight north, south to north groundwater flow. And you can see with the barrier wall and sort of the contouring around it, we've got a lot of aggressive, water movement going on around that barrier wall now without stagnation zones. And on the right is a sort of depiction of what's going on with the plume. As you would expect, the overall dissolved plume is not dropped because we're not remediating the overall dissolved plume. We're treating the higher concentration areas. So you can see the pink to red is 1 year of the basically the remedial goal objective concentrations, but the down towards the higher concentration towards the wall, you can see the change. Like the light green was our natural attenuation default concentrations of benzene and naphthalene. The dark green is where it is now. The light blue was where we were baseline. The dark blue is where we are now. And on the southern side and southwest side, you essentially don't see much because that whole sort of plume to the south and southwest is essentially gone. There's only one well on the south side of the barrier wall that has as low concentrations remaining in it. I think that's all I have for you. Again, tried to take 7 years of information and cram it into a 20 or 30-minute presentation. Anybody has any questions, be happy to answer. Thank you.
So the historic bricks, you counted them and then threw them away. What was the story behind that?
Yeah, I almost need to have a beer to have a story about the historic bricks. The road is paved, but there's historic bricks underneath it. Any kind of the city wants those bricks because when they do redevelopment or clean or fixing up other areas of downtown, they want to have bricks in their brickyard to do restoration work. The PRP group was arguing, well, those bricks are potentially, they're impacted media. They cannot end up in a potential playground. The city basically said, well, you then have to, replace the bricks that you're getting rid of. And they're like, well, the bricks were under the road. You weren't using them anyway, but they're like, well, we may have in the future. So we ended up having to do geotechnical analysis on the bricks, get specs on those bricks, and then find a source to purchase historical bricks that met the spec or exceeded it and looked the same as the bricks we were removed from the road. So we did end up finding a facility in Indiana that had historic bricks, and we bought 12,276 bricks and had them delivered on steel pallets and delivered to the city's brickyard. We kind of laugh. We always kind of kid around that they probably came from somebody knocking down an MGP site in Indiana. But you know, that's sort of the story of the brick saga. And it was pretty expensive, obviously, to get bricks from Indiana that met the spec and delivered to the site so that everybody was happy. Other questions? Oh, and for this, what we used to define mobile NAPL was a location where we put in a piezometer, screened interval in the zone where we identified, you know, staining or visual observations of MGP residuals in the subsurface. We screened that zone and then measured for NAPL 48 hours or after installation, and then 48 hours after installation. We were going to originally we tried negotiating for 24 hours. Agencies pushed back and we said, how about 48? And they were like, okay. So we basically used that. It was a quick and easy way. 48 hours. But if we did see the mobile NAPL, we purged it, and it had to rebound within another 48 hours at a thickness of greater than 0.01 foot, which sort of ties to some Florida rule as well, regarding what would be defined as a free product in this situation. So it was kind of a combination of sort of what Florida would require and what we can negotiate with the EPA, because we're dealing with two agencies on that. So we arrived at this 48-hour monitoring and 0.01 foot thickness. And we had language in there that the groundwater elevation, the static elevation, couldn't move by more than 0.01 foot, because technically if you had the groundwater elevation bounce up and down in an area where there's LNAPL, you may have just exposed, you know, you may have contributed LNAPL to the well. That's really not representative of mobility, but just representative of accumulation because of a water table fluctuation. So we had language regarding water table fluctuation, the 48 hours, and the 0.01 foot thickness. We did not find any mobile DNAPL. Even though we did hit areas that you could clearly see there was coal tar residuals, staining, blebs, tar-coated soils in the deeper zones. Of course, these are areas that are inside the barrier wall anyway. One would argue, why would you even ISS or worry about it? It's inside a barrier wall, and that's because since this is a Superfund site and EPA was involved, they considered NAPL a principal threat waste. So since it was a principal threat waste, it needed to be dealt with. So there's why we ended up solidifying NAPL inside a barrier wall where it wasn't going to go anywhere. It was the same criteria for DNAPL and LNAPL, yes. I'd have to look. I can't, that's going back 7 years. I don't want to say yes or no because I wouldn't be 100% confident. I'd have to talk to our geologist that was sort of running that part of the program. My gut feeling is they did have some minor development associated with it right upon installation, but I'm not 100% sure. Good.
All right, well, thanks to the panel. We have a few minutes, so I just wanted to see if anybody had any final questions, given the level of experience and expertise we have up here. All right, well, thank you. If not, we're now on break. We'll be reconvening here at 10:30.